Hi, welcome to Manish IT. This is Manish. Today I am going to discuss about stack. So before discussing, we know that we have seen array, and I also know about array working, how data is stored in array, what are different operations and array, like that. So now we will see what is a stack data structure. So you can say it is a linear data structure. Let us see first how we can understand a stack property. Suppose we having some collection of books, that is physics, chemistry, mathematics, programming and English, and all, and we are arranging here on top of each element, top of each other. So now suppose I am asking to user, give me chemistry book, then user are doing simply it, choosing easy path. What is easy path? Easy path simply the user lifting all these books and pulling these chemistry books and give me. So see how it's happened like this. So now suppose I am suppose I am taking arranging all these books inside the limited size of box, and that box having one opened path. So topmost is open, so inside box simply all books are arranging in the same condition. And now once again I am giving message to user, give me chemistry book, then what's happened? So see, this condition is not similar to this case condition. So say, see here, only one condition to pulling out chemistry book. First you have to first you have to take out English book. So English book is there, then programming book, then mathematics book, and we found our book which I needed. So that is chemistry book. So now we take out this chemistry book and simply give me like this. So similarly in a stack same thing is happening, because of insertion is from topmost and deletion from topmost. We can say this box is, it is a stack and it is collection of book. So now we can see another example for a stack using bangles. So see here, suppose someone is wearing bangles like red, green, purple and blue, and if you are want to take out this green bangles, then green bangles from out of hand without broken this bangles. So then how it can be possible? So only one way it can be possible. First you have to remove this blue bangles, then purple, then you got green bangles. So see how it can be happen. So see, this now purple is removed, and once green is getting. So this same thing is happening in the stack. But as we know, every function having their own rules and property, then a stack having also own property, and see one by one what is their property. So see here, a stack is also and order collection of elements like array, but it has a special feature that deletion and insertion of elements can be done only from one end, that is called top of the stack. Next one is, due to this property it is called last in first out or first in last out type of data structure. And next, it is non-primitive data structure and linear type. Next is, when an element is inserted into a stack or removed from the stack, its base remains fixed where the top of a stack is changes. So next is, insertion of element into a stack is called push, and deletion of element from a stack is called pop. So see here, operations and applications of a stack. Operations are pushing, it is nothing but to insert a new element inside the stack. And pop is removing the element from top position. It's working. So and top is nothing but whenever you are entering then top is automatically incremented, and it's locating that position. And peak is nothing but whatever element at the top position, that stores in peak. So traverse is nothing but it is displaying of all the element inside the that inside of the stack. So application is one of the most common application, that is printer. Whenever you are inserting any documents inside printer, and simply you are seeing there getting only one output at the one time, at the same situation. So you are inserting one documents and getting one, inserting means they are pushing one document, and one when you are getting then popping only one documents. So that is common application of a stack. See here one example. This is a collection of chair, and from top position I am counting here, this is the third location. So if you want to remove this third chair, so it cannot be possible directly. So if you have to first remove this first chair, then second chair, then you got your position and you are getting this chair. So this way same thing happening into the stack. So now question is that we understood all things about a stack, but how can implement it by programmatically? So don't worry, let us see about implementation of all above of all these operations in a stack one by one. So next, our first operation is push. Push is nothing but it is insertion of element into the stack. So this program is not completed complete program. So it is only a pushing push function. This program is written for only push function. So after discussion of all operation of a stack, we are going to implement all the program, all this function program inside one program, and executed that program at the end of video. So here see our stack, this is our stack, and pushing in of that is insertion of any element from topmost position. So let us assume our stack size is 5. So see this 1 2 3 4 5. So always topmost element is initialized with -1. So here top is initialized with -1. So here indexing is started from 0 1 2 3 4. So now if user want to insert any element, then how to write. So white push, and inside we are giving parameters integer type, that parameters name is and variable name is num. So there we have to check our condition, this stack is full or not, because of our array size is 5. So that's why we have to check our condition is it is full or not. So here condition is whenever this function is full, function is calling inside if condition, then it's come our compiler goes to if its declaration part. So here it's declaration part. So if top is equals to maximum -1, maximum is nothing but it is our size of a stack. So our size of a stack, already I told you our size of a stack is 5. So 5 minus 1, that becomes 4. So here top is pointed to -1. So -1 equals to 4. Our condition is not satisfied. So simply it's executed else part and return 0. Return 0 means here also executed else part. It means simply you have to give a message to user, enter your data. So in on the screen it is printing like enter your data, and user enter some value that stores in number. So that value is entered, then we have to first increment our top position, then we have to store that number into the stack. So after incremented and storing that value, so suppose user entered 10, then how it's looking like this. So our top is pointed to 0, and it is entered and stored in our stack. So simply on the screen giving message like 10 is pushed successfully. Now again user want to enter some value, so again push function is called, and again it's executed from the beginning, and checking condition like is full condition is satisfied or not. So each full condition is not satisfied because it top is pointing to 0 and 0 is equals to 4. It's not satisfied, so else part is executed. Else part means this one. So once again it's giving a message to user and taking a value from user, and top is incremented, and that value is stored in our stack. So see how it's happened. So top is incremented and stored in this. It is simply this. Whatever, whenever you are calling, you are call this push function, how many times you are calling, that times it executed from beginning. So suppose you once again user called push function, so it's happening like, and first incremented top and storing value 30. Once again user called push function, it is incremented and storing value 40. Once again user called push function, and it is incremented and simply storing some value like 50. And it's once again user want to insert some value, then what's happen, then once again user wants, then all push function is calling. Whenever push function is called, it's once again executed from beginning. I told you clearly. So here if full is condition, if a condition is then our compiler goes to full definition part. So is full, top is equals to max minus 1. So top is here 4 and maximum 5 minus 1, that is 4. 4 equals to 4, condition satisfied, then returns 1. Returns once means it is printing simply stack is overflow. The overflow is nothing but stack is full. So it's giving a message to on the screen, your stack is overflow. So it is simply we understood like our stack size is full, we cannot insert any further element. So next we are discussing about pop function. Pop is nothing but it is a deletion of or removing of element from topmost position. So see here in this situation, top is pointing to -1. So suppose here our like the return value pop function is return value integer type and inside void. So why I am taking integer here, because of in the top always whenever pop function is called, it is simply removing integer value from topmost element. So that's why it's return some value integer, it's return value. So simply it's executed, and if function is once again it condition is checking like if is empty. So is empty function is declaring here whenever our compiler is coming here is empty function. So our compiler search within the program where is empty function definition. So it's coming here. If here checking once again, if top is equals to -1, then it returns 1, otherwise it returns 0. So see here our top is -1. In this situation our top is -1, so condition -1 equals to -1, so it returns simply 1. So it returns simply 1, that means it's simply printed like stack is underflow, that means empty. So next suppose in the our if is empty function is working is finished. So see this if in the back situation, if there is a element and suppose our top is pointed to like a fourth position, then what's happened. So in this case, so once again pop function, whenever pop function is called, so always executed from beginning. How many times you are calling pop function, always then that many times it is executed from beginning. So suppose you are calling pop function and then it is executed from if int value, and if condition is empty or not. So is empty, here declaration part is coming and top is pointed to 4. 4 is equals to -1, condition fail, and is return value 0. Return value 0 means it's stored inside this integer type value stores like a stack of topmost, and this topmost element is removed and also decremented by 1 at the same time. So how looking like this, see it is removed and top is decremented and pointed to fourth location. So once again user want to once again user called pop function. So once again it is executed from beginning, and checking all these conditions accordingly to our whatever program return instruction. So when is empty is not satisfied, then it returns 0 and else part is executed. Once again it is else part executed, so the top is 40 is removed and top is decremented and is pointing to third position. Once again pop function is called and 30 is removed and top is pointed to first location. Once again pop function is called, so 20 is removed and top is pointed to first location. Once again user want to remove 10, so pop function is called, so it's simply removed and top function is simply pointed to -1. Once again user called pop function, then what's happened, then our top is once again pointed to -1. So it is simply going through our declaration part of pop function and is simply checking is empty. So is empty condition is here. So if top is equals to -1, so top is also -1. So here -1 equals to -1, condition satisfied, it returns 1. Whenever it returns 1, it is simply executed, stack is underflow, that means empty. So whenever this statement is printed on a screen, so user understood stack is empty, so there it means they are having no any element. So our pop function is finished. See, another function is void peak void, because void means it nothing return to value. So once again peak is nothing but I already told you, peak is topmost element of the stack. So see this peak here in this case, peak is what top is pointed to -1 and in the -1 location there is no any element. So top is simply it's printing and -1 it's satisfied condition empty, so it is simply printed stack is underflow. Suppose if top is pointing to this location, fifth location, and here 50, suppose here elements are 50, then simply it's printing top element in the stack is 50. Suppose top is pointed to third location like this and here is 30, so it's simply printed like top element of the stack is 30. So like this our peak function is working, it is very easy. So see how it traversing is nothing but to display all the elements of the stack. So here we are declaring void, it is its returns type void and also no such a parameters. So inside declaration part you see integer I here by here capital I, sorry for that, it is by mistake written, you have to erase it and write like my like a small I. So once again if condition is there, if is empty, suppose if a stack having no element, so how it can be printed. So that's why we have to always check our condition. So is empty is condition satisfied, so then it's simply printed a stack is underflow. So otherwise it is executed else part. So else part having like printed simply elements of a stack and on another is printed bottom to top. So it is it's this value is printed by two way, like top to bottom and bottom to top. So if you user want to printing like bottom to top, then what's happen, so our we have to write our logic accordingly inside for loop. I is equals to 0 and I is less than or equal to top and incremented by 1. So simply it's giving a value of a stack of I. So and if you user want to print top to bottom, then I is equals to top and say I is greater than or equal to 0 and decremented by 1 and printing simply and stores in stack of I. So simply how it's printing like this. So see on the screen this print whatever printed elements of a stack, this things is here printed, and this bottom to top element is 10 20 30 40 50, 10 20 30 40 50, top to bottom 50 40 30 20 10, and top to bottom here also 50 40 30 20 10. So these all implementation of these all operations of a stack we are going to implementing in our program. So how it's how we can all these function written in. See. how it's working, like here all operation of a stack is there, and we are simply written basic things has include stdio.h as and has include conio.h, and we are another we using preprocessor, so has defined maximum, and our size is fixed there, so we are declaring integer type of a stack max inside we are passing maximum because of we already max it is a constant, so that's why it can be taken, not it not giving error. So top is in a slide with -1, and here we are simply declaring all these functions void push integer, we are passing integer type. We all seen this all function in the previous presentation. So integer type of it is full function, and int pop is a integer type of pop function, int is empty, and a void pick void function, and void to traverse display to display. Our main function is started from here. So see here integer type of ch is nothing but it is integer type, and it's for our choice. So and data, so we are taking clear, we are calling clear function, and while function is called, and it's executed unlimited time because of we are passing a value like 1. So we are printing some message to user for one if user enter one, then push, and second choice for pops, third choice for pick, fourth choice for traverse, fifth choice for quit from program. So we are giving a message enter your choice, and simply scanning that value choice value, and simply we are calling switch function, and inside switch function we have to pass our choice. So we are passing our choice, and inside case 1 we are simply calling push function with parameters and integer type, and we are again calling traverse function to displaying all the elements inside the stack, whatever that is stored in to the stack. So that's why we are calling this function. So again it's we it is compulsory, it is compulsory to switch case break function is used, because of you are not using here break function, then it is executed case 1 all or whatever calling function is in case 1, and whatever calling function in case 2 simultaneously. So that's why we have to break function whenever this push function is executed, traverse function is executed, and it's coming to print function, then again it's coming to break function when our compiler coming to break function, it's exist from our loop. So in case 2, simply our data we are storing our integer, it is gives our integer type return value, so that's why data is stored in pop is stored in data, and simply printed that data popped element is this. So and calling traverse function, so simply in third case pick function is called, and break is used, and in case 4 traverse displaying function is called, and break is used, and in case 5 we have to exist function is used, and passing 0 parameters to exist from our program default here because of every switch case having a default value, so we have to use here simply give a message to user if user entered some extra value from 1 to 5 like 0 or greater than 5, then it simply giving a message in valid key entered. So now our push function is called here, and inside push function we are passing some integer type number, and if condition is full, then it's executed printf this line, and other condition is fail, then else part is executed, and top is incremented, and that number whatever number given by user, that is stored in a stack of top. So again full is full function is declaration part. If top is equals to maximum -1, then it returns 1, otherwise it returns 0. So next one is pop function. Pop is pop function having return value. So see this pop is integer type, so we have to take one integer value. So if we have to check once again our condition is empty or not. So if is empty condition is satisfied, then it's simply printing a stack is under flow, otherwise it executed else part, and simply it's like storing value at a stack of top incremented. So and it gives a return value of this value. So our age empty function is declaring here, if top is equals to -1, it returns 1, otherwise it returns 0. So here pick function is calling here. So if pick function is there, so if is empty function is satisfied, then it's printing like a stack is underflow, otherwise it's printing like whatever topmost element of inside the stack that is printed. And whenever traverse function is called, so we are here using, see here in our presentation there is mistake, we are using capital I, but you have to erase that and written like a small I here. I am calling simply is empty function, and simply we are printing like a stack is underflow, and if condition is satisfied, is empty satisfied, then it is printing like this, otherwise it's printing like this. So in this situation we are printing like bottom to top, and simply we are written like according to our rule, whatever our algorithm, we have to write using for loop, and I is initialized with 0 and I is less than or equal to top, I incremented and simply printed that value. So similarly it is when you want to print that top to bottom, so you have to write like this your. So now I am going to compile it and see what's happened looking. So it's giving us 0 0. So now we have to run this. So after running this, it's asking to suppose in the starting I am directly calling display function. So see this, the stack is underflow. So now again I want to push some elements. So I am entering some 10 value, and I see this 10 is pushed successfully, and elements present in a stack is top, from bottom to top are 10, top to bottom are 10, because of only one, there is only one element. Again I have to insert some pushing some value. So 20 is inserted. So see this, the top to bottom is 20 10, and bottom to top is 10 20. So again I want to insert some value. So 30 is inserted. uh, 30 is inserted. Then see this, our stack is like this. So I am calling pick function. So simply I am choosing third option. So see this, top element in the stack is 30, because of in the last we are inserting 30, so 30 is the topmost element. So now you are calling pop function. So see this, how it's working. Whenever 2 is inserted in our choice, so it's going to simply popped element is 30, and inside the stack whatever element is rested, that is 10 and 20, from bottom to top, and top to bottom is 20 10. So once again I am calling pop function. So see this, only stack having only 10 element. So once again I am calling pop function, so it's having no element, so that's why it's printed like a stack is under flow. Now I am going to insert some element, like push function is called. So 10 is inserted. Once again I inserted, so like 20 is inserted. Once again I inserted, like 30 is inserted. Once again I calling to push function, 40 is inserted. Once again I calling to push function, 50 is inserted. Now it's equal to push function. So once again I want to insert it one. So see this, what's happened. So simply it's giving a message, the stack is overflow, it reaches the maximum capacity of a stack, so we cannot insert any further element, so we have to remove this all things. So suppose we are calling simply our function pop function, so simply 50 is removed because of last element is 50. So now if I am quit from this program, so simply I have to enter 5. So 5 is entered, so I am getting quit from this program. So these all are execution part of our programming. So if you having any question, then please comment in the comment box, and if really this video is helpful to you, then please share with your friends and subscribe my channel. So thank you for watching and listening my presentation. So